This is David with ISP App, and today I'm going to be talking about what makes ISP App unique amongst MikroTik router OS management platforms. The main thing that makes ISP App unique is that ISP App uses HTTPS outbound connectivity. What that means is that you load a script onto your MikroTik router, and then that router connects to your private cloud server every minute or so, and lets the server know its performance information and where it's at. And that's quite different than the traditional ways that this is done. So the traditional ways that MikroTik management is done is you have a central management server, and it reaches out to the devices, looking for those devices at specific locations. So a classic example is or a common complaint that I often hear is that the ISPs will get false offline notifications. They'll get false alerts that the devices and the subscribers have gone offline, even though the subscribers are online. So how that happens is that the server's looking for those devices at a specific IP address, and the IP address changes. And when the IP address changes, then the server thinks it's offline, even though it's actually online. And some people say, well, you can just use DNS. And so then you look for those devices at those DNS, the DNS entries. Problem with that is that now you've got another layer. And so now if the DNS changes, then the device shows offline because it can no longer be found in the DNS server. So that doesn't actually get you anything. Another way that cloud management systems often look for devices is through VPN tunnels. And so what happens there is that the VPN will break. So for whatever reason, the VPN disconnects, and now the management server can't reach the device. And in order to restore the management connectivity, you have to reach out to the subscriber and ask them to reboot their device to restore the VPN connection. But that doesn't make any sense because the subscriber doesn't care about your management system. They just care about their internet service, and they don't want to be bothered to reboot their device in order to restore the VPN connection. Similarly, another common problem would be management protocols. So you're using SNMP to manage the devices, and for whatever reason, the SNMP protocol breaks. Again, no problem with the internet, no problem from the subscriber's side, but just a problem with the SNMP protocol. So what could happen there is a firewall gets put in place that blocks the SNMP traffic. The subscribers' outbound HTTPS traffic still works. They still have internet connectivity, but the SNMP ports are blocked. And with ISP App, because we're going in the same direction, basically from the subscriber to the internet, so outbound, and we're using browser protocols, HTTPS, so we're using the same protocols going in the same direction as the subscribers, our software is able to better represent the actual subscriber experience. So what that means is that when this says it's 99.99% online, it's 99.99% online, and you can trust that ISP App is doing an accurate job of representing the actual state of the subscribers. The other advantage of that is that ISP App keeps track of your devices. So as long as they have internet connectivity, then you can keep track of your devices. So here we can see that this device is telling ISP App, I've got these interfaces, and these are the MAC addresses associated with those interfaces. And this is the WAN interface IP address. So this is the IP address associated with my WAN port. And ISP App sees that it's reporting from this IP address. So here we do an IP address print. We see that this is the IP address associated with this interface, and it's a DHCP client address. So we know that Ether1 is the WAN interface, and this is the IP address that's associated with it. And again, that matches this. So this is also super unique. So this is a web shell. We can run a IP service print. And so from the ISP app dashboard, you're able to send commands using the web shell to your device. And the device then responds and shows us that all of the services, all of the inbound management services are closed. They're all disabled. So typical management systems need to have SSH or the API or Winbox listening and open in order for the server to communicate with the devices. With ISP App, you can close all of the inbound management ports and still have IP layer control. So ISP App keeps track of your devices. It does a better job of representing the actual state of the devices, and you can control your devices using Outbound HTTPS and totally secure the inbound management ports on your devices. So all of that makes ISP App totally unique. But there's a lot more. So here we've got bulk commands. So just like I did this IP service print, I could enable Winbox, and I could enable Winbox on all of the devices in ISP App all at once. So I send one command to enable Winbox on all of the devices. Say if I wanted to spend an evening doing management, I could access the Winbox port on the devices, and then all at once at the end of the night, I could close it back down again. So very useful to be able to send commands. I can enable roam on all the devices, and then when I'm done, disable roam on all the devices again. Here we showed the existing wireless networks. So these were the wireless networks that were set up on the device when we loaded ISP App onto the device. And here we can add additional virtual access points. So we can add additional Wi-Fi networks through ISP App. We can load subscriber info. So this is the information about the subscriber. We can see here, this is the wireless performance information about the device. So we can see on WLAN 1, not very many devices connecting on WLAN 1. But on WLAN 2, we've got 5 devices that are generally connected and 5 devices that are connected right now. We get the signal to noise. We get the individual signal strength. If we click on one of these devices, then we can see the signal strength over time, and we can see the bandwidth, the traffic utilization of this device over time as well. So using this information right here, we can get a clear view on the Wi-Fi performance of this MikroTik router. And then down here, we can get a good view of the internet performance of this router. So we can see here that this router is able to ping this server with very steady 60 millisecond pings. Down here we see that we're pinging this server with very steady, it looks like about 85 millisecond pings. And so we're pinging 4 different servers all around the world. Down here we get to see the traffic. So we can see the traffic on the bridge 1, which is the LAN bridge, and then we can see the traffic on Ether 1, which is the WAN interface. And you can see that Ether 1 essentially is a reverse of bridge 1. And we can see that for the most part, not used much during the day, used a little bit in the afternoon, and then I guess they called it a day. So down here, we can see the system load and process count. So we can see that the processor was utilized for much of the morning and into the early afternoon, and then it says up there, we can get the cursor on there. It says process count 21, and then it goes down to process count 19, and then the processor utilized a lot less down here. So there's a story there. I'm not quite sure what, but if you had performance problems, you could investigate what process was it that was causing all these CPU cycles. So in summary, ISP App does a better job of representing the subscriber experience because it's going in the same direction and using the same protocols as your subscribers. And using ISP App, you can totally lock down the management interfaces on your device. And it's those management interfaces that often get exploited by zero-day exploits and by botnets and compromised passwords. So for all those reasons, it's a good idea to close down those management interfaces, and it's a good idea to use good architecture, which is what ISP App has built. Thanks so much for watching.